Okay, obviously, in order to do any of this, we need to conduct a survey first so we can take a sample. Now, I used to work in market research, and I used to be one of those people that called you at dinner time and lied to you and told you the survey would take 5 minutes and it would take 2 hours. But here's the thing. You have to pay people to conduct the survey. Sometimes you have to pay people to get them to do the survey. So it can get expensive. So you want to survey the smallest number of people possible so that you can be as confident as you need to be, but don't survey more than that because it wastes money. So here's how we find the sample size that is necessary for estimating a population proportion to within a specified margin of error. So our sample size is the sample proportion times 1 minus the sample proportion times z sub alpha over 2 over the margin of error squared. So the sample size, of course, is n. The critical value for the confidence level is z sub alpha over 2. So remember we talked about in one of the previous videos how we had these cutoffs and our confidence level was here in the middle, and the parts on the little tails were our alpha over 2's. That's an alpha over 2, and this is an alpha over 2. So these two cutoff boundary lines here are the z sub alpha over 2. And really we just want the positive one. We don't care about the one on the other side. So the other thing we have is the sample proportion, which is, we've talked about that a bunch of times. That's our x over n. And we need our margin of error, E. So here's what I've done. I have given you the confidence levels ranging from 90 to 99%, and I have given you the critical values associated with those confidence levels. You may use this on your test to calculate these sample sizes. So let's do an example. So if we have no prior estimate, or we don't know what the sample proportion is, we use, so when we don't know the sample proportion, we use 0.50. In other words, we assume that 50% of the sample, individuals in the sample, have that characteristic. So a researcher wishes to estimate the proportion of households that have broadband internet access. What size sample should be obtained if she wishes, so here's the key words, what size sample should be obtained? That means find the minimum sample size. If she wishes the estimate to be within 0.03 with 99% confidence, if she does not use any prior estimate, well, n is p hat times 1 minus p hat times z sub alpha over 2 over the error whole thing squared. So if we just substitute in our numbers, our p hat, we don't know it, so that means it's 0.50. And then we have 1 minus 0.50. Now let's see. Our z alpha over 2. And we want to write this whole thing down because it's more accurate if we do not round our critical value. So for 99%, we can go back up here and look. And here it is. So to write that down, we have 2.575 829,303. And we're going to put all of that over 0.03. So one thing to note here is within is our keyword that lets us know that that's a margin of error. And then we close the parentheses and square this. So if we want to type this in the calculator, we have 0.50, or just 0.50, open parentheses, 1 minus 0.50, close parentheses, open another parentheses, 2.575829,303, divide by 0.03, close parentheses and hit the x squared button, and then hit enter. So we get 1,843.03 if we round to 2 decimal places. So that gives us n of 1,843.03, or 1,844 households they need to survey. Now, some of you may be saying, wait a minute, if you round that to a whole number, it should round to 1,843. You are absolutely correct, but when we're doing the minimum sample size, we always round up to the next whole number. Unless we get an exact. If we came up with exactly 1,843, then we would leave it as 1,843. The problem is in order to be within 0.03 for our margin of error, we have to survey 1,843 households plus the 0.03 of a household. Well, how do you survey 0.03 of a household? You can't. So you have to go up to the next whole number, because rounding down to the previous whole number would not give you quite enough people. Okay, let's try a second example. What sample size should be obtained? So this is the same setup as the previous problem. What sample size should be obtained if she wishes the estimate to be within 0.03 with 99% confidence if she uses a 2009 estimate of 0.635? So this right here gives us a previous estimate for p hat. So that part means that for p hat, we're going to use 0.635. So remember, n is p hat times 1 minus p hat times the critical value for that given confidence level divided by the error squared. So that is 0.635 times, in parentheses, 1 minus 0.635. Oh, sadly, our z sub alpha over 2, that critical value, is still that big long number, 2.575829303, divided by the error, which is still 0.03, and we have to square that. So in this case, when you type it in the calculator, you get N is 1708.67. And again, we always round up, even though this one would normally round up. So we need 17,009 households. All right. That concludes section 9.1. In 9.2, we'll discuss the same topics, but for estimating a population mean instead of a population proportion.